So in continuation, now last class we had learnt about Vrms is equal to Vmax by root 2, right?
Yes, sir.
And average, what is the formula for average? V average is equal to V 2Vm by pi, right? You know, Vrms is equal to Vmax by root 2, correct?
Yeah.
And V average is equal to 2Vmax by pi. Let's take example like this. We took one example. V is equal to given 220 root 2 sine 314 minus 5, right? Volt. This is the value. One value is given. He is asking to find peak value, RMS value, average value, and frequency, right? Let me want to find peak value, RMS value, average value, and frequency of this wave, of this signal, right? So what is the peak? What is the peak value here?
220 root 2.
220 root 2, right? Sometimes you may multiply 220 into value of root 2 is 1.414. That will come about near 311, right?
Okay.
And what is
And
Vrms?
Vrms is equal to 220 root 2 by root 2,
Yes,
220.
Vmax by root 2, that is 220 root 2 divided by root 2, root 2 cancel, that is 220.
Yeah.
Correct. This is
And then
case of X. Then V average is equal to 2 Vmax by pi.
yeah, so 220 root 2 by
So this
pi.
2 by pi into 311, that is equal to 198.17 volt. Correct.
Yes.
And what is this place of omega? This is right.
Yeah.
Sine omega t minus phi. Correct. Here t is there. Sorry, we left this t is there. Correct.
Okay.
This is omega t. So
The
omega t is
envelope.
314t. That means omega is equal to how much? 314. And from there you can find omega is equal to 2 pi f.
2 pi. Yeah.
That is 314. So f is equal to how much? 314 by 2 pi. That is equal to 50 hertz.
Yes.
Correct.
Yeah.
This is the basic type of question, right? Understood?
Yes, sir.
Let's take another example. Right. It is given a current is made up of two components, a DC component and an AC component, right? There is a current where some DC is there, some AC is there. Understood?
Yeah.
A question is that the current is made of two components. There is a DC component. DC component I1 is equal to 3 ampere and an AC component I2 is equal to 4 root 2 sine omega t. Understood? This is given DC component, this is given AC component, right? Find the reading of hot wire ammeter. Find the reading of hot wire ammeter. Correct?
Yes.
Ammeter reads what? Which current? RMS.
Current.
Yes, ammeter reads
Yeah,
which
the
current? It reads RMS current. That means he is asking about RMS, right?
yes.
And the total current is what? Component of it means the total current is mix of AC and DC. That is I1 plus I2, right? That is equal to 3 plus 4 root 2 sine omega t. Yes or no?
Yes.
So if I'm interested to find IRMS square, right? That is equal to We'll integrate 0 root t I square dt, correct? By dt 0 to t. Yes or no? Then that is equal to
So where did you get this from?
formula we have derived, formula for IRMS,
Yeah.
total RM, value.
Okay, yeah, got it.
So this
Yes.
is 0 to t. Let's put the value of I. That is 3 plus 4 root 2 sine omega t square dt, right?
Hmm.
By t. IRMS square is equal to 1 by t integration 0 to t 9 plus a प्लस बी का होल स्क्वायर ओपन कर देते हैं, ठीक है? 3 का स्क्वायर 9, 4 रूट 2 का 16 इंटू 4 24 रूट 2, राइट? साइन ओमेगा टी, करेक्ट?
16 into 2, sir,
No,
which
2ab.
will be 30.
Yes, 2ab, 2ab.
Okay.
And that is 32 sine square omega t, correct?
Yes.
Into dt, correct? Understood? Yes or no?
Yes, sir.
So if we'll integrate this one, 9 dt is 90, right? 24 root 2 means sine omega t by omega.
Minus cos omega t
Hmm.
by
30
omega.
sine square omega t as we did, right? So
Yeah.
total value you find, then you find the limit from 0 to t, you will get IRMS, correct?
Okay.
That will be near about 5 ampere.
Fine.
Just check it out, okay?
Yes.
Let's take another example, graph type question. We'll do later on many examples, but now see.
Sir, last class I had sent a few doubts.
Doing that. Okay. There is a direct current. In the, ये हुआ एक वैल्यू दिया उसने, डीसी का वैल्यू दे दिया, एससी का वैल्यू दे दिया, राइट? करेक्ट. अभी वो डायग्रामेटिकली दे रहा है कि there is a direct current, yes or no, and AC is
Okay.
imposed on that.
Fine.
So direct current means like that he has given the graph. This is the time axis, and this is I DC, correct? This
Okay.
value is A. Yes or no?
Hmm.
Correct. Understood? This is DC. Magnitude is A. Here is also T. This is current I. This magnitude is B, right? This is AC.
Hmm.
And this magnitude is B means it can follow the equation. This can be B sine omega t, right? This wave equation.
Yes.
So if we want to find the total current, then I is going to be how much? IDC plus IAC, correct?
AC. Yes.
IDC is fixed A plus IAC is B sine
Sine
omega t,
omega t.
correct?
Yeah.
Then I effective is going to be like integration of 0 to t, right? I square
Hmm.
dt integration 0 to t, right? This is I effective का square, correct?
Yeah.
At last we will find the root over value. ठीक है? So as you know, always dt is 1 by t denominator, right? Integration 0 to t inside a plus b sine omega t whole square, correct? Dt. Yes or no?
Yeah.
So that is equal to how much? 1 by t integration 0 to t s square plus 2
AB sine omega t.
hmm, 2ab.
So, sir, we'll get the answer like root of a square plus b square, right?
Yes. Let's see. 2ab sine omega t plus b square sine square omega t, right?
Yeah.
Dt. Yes or no?
Yes.
But for full cycle sin omega t integration is how much? Zero, na?
0.
To be sin omega t, to be come out, to a be come out sin omega t integration 0 to t is 0.
Yes.
Means integration of anything written, but that is constant, it will come out sin omega t integration 0 to t, that is going to be 0, right?
Yeah.
Then if we take the integration of sin square omega t in terms of cos, you break, okay, 1 by
Hmm.
t, 0 to t, it is going to be somehow 1 by 2, right?
Hmm.
So totally if I'll go for I effective, then I have to make the root over, right? That is
Okay.
s square
Huh.
plus half into b square was here constant
Yes.
to the power half, correct? Root over हो गया.
So where did you get half?
Root over पर we had
No,
taken
where did you get half b?
हाँ आई इफेक्टिव का स्क्वायर लेते हैं, जब आई इफेक्टिव निकालेंगे तो रूट ओवर करेंगे ना, रूट ओवर मतलब टू द पावर हाफ.
नहीं सर, हाफ b स्क्वायर कहाँ से मिला?
ये जो बिस्कर साइंस का ओमेगा टी का हमने निकाल दिया हाफ, बिस्कर था ना यहाँ पे,
Okay. हाँ.
दैट इज द थिंग. ओके.
Yeah.
Then last class also I had taught you about phase difference, sin omega t plus phi, sin omega t minus phi, right?
Yeah.
How it leaks, how it lags. Okay. So let's now today directly go to AC through resistor, right? AC through resistor, AC through inductor. Let's see today. Okay.
Okay.
Hmm. Keep hearing. AC through resistor. AC through resistor, right? Students, pure resistor of resistance R is connected across an alternating EMF, right? हमने यहाँ पर एक
Hmm.
resistor लिए जिसका resistance R है, and we have connected it to an alternate EMF, correct? That is E is equal to E naught sin omega t, correct?
Yeah.
So the instantaneous value of EMF is E naught sin omega t, correct?
Huh.
And student, the instantaneous value of alternating current will divide by R, right? Instantaneous value of alternating current, that is I is equal to E by R, correct?
Hmm.
And that is E naught sin omega t by R. And E naught
Hmm.
by R is I naught. E naught by R is I naught. So I
I
is
know.
equal to become how much? I naught sin omega t. Correct?
Okay.
Yes or no? Then peak
Yeah.
value of current. Peak value of current is nothing but I naught is equal to E naught by R, right?
Hmm.
Got now? Then we'll go for the phasor diagram. How the voltage and current, right?
Phasor diagram.
Yes, how the voltage and
Okay.
current waveform go, they remain in same phase, right?
So could you scroll up once?
Yes,
Okay, fine.
phasor diagram. If this is EMF, correct? We've taken this one as omega t, this one is I or E, right? If this is EMF, then current is somehow magnitude is less because it is getting divided by resistance, right? It will be in the
Huh.
same page where started, where it is touching to zero, then this can be the current waveform, right?
Okay.
This is EMF and this is current. Correct. Let this is 0. So this is going to be pi by 2. This is going to be pi. This is going to be 3 pi by 2. This is going to be 2 pi. Correct? Yes or no?
Yes. Yes.
This is in the form of waveform. But we'll be taking in the diagram like this. If this is y-axis, this is x-axis. So here what is happening? If this is the direction of EMF, this is also the direction of current, right?
Hmm.
EMF and current will be in phase, right? EMF and current will be in phase. EMF and current will be in phase, correct? And
Yes.
that is delta phi is equal to 0.
Hmm.
Or here, purely resistance, right? So EMF and current have same frequency also. EMF and current have same frequency.
But the current value will be always less than the EMF.
Yes, definitely, because it is getting divided by resistance now.
Hmm.
And peak EMF is always more than, as you told, peak current, right?
Yes.
And I had also told you about inductive reactance Z, XL, right?
Hmm.
And here the impedance Z is equal to R only, right?
Yes.
Impedance Z is equal to R, right?
Hmm.
And reactance X is equal to 0. Mhm. Understood?
Yes. Yes.
Instantaneous, apart from instantaneous value of current, that is independent of frequency, right?
Hmm.
But see, if the RMS current I is inversely proportional to R, na, if current will go on increasing, okay, if resistance will go on increasing, then current will decrease, correct?
Hmm.
So that means indirectly I want to say if this is omega or frequency axis, right? And this is IRMS, right? So there is no, the slope will be constant. Constant current will flow if current is a particular amount current, right? It is not going to, current is not going to by the change of frequency or the omega, correct or not? It will be always I naught by root 2. Getting?
Okay.
Resistance is constant. But if we'll draw about IRMS and in general, if this is the current and this is the resistance, then it is going to decrease like this, correct?
Okay.
1 by R. Understood?
Hmm.
And I also told you power factor, cos phi. Told or not? Power factor.
Yes, we do.
Power factor.
RMS value by R.
Yes,
Average.
power factor cos phi. Here no phase difference, so cos 0, that is equal to 1, correct?
Okay.
And instantaneous power, that is P instantaneous is equal to E naught, I naught, sine square omega t, correct?
Hmm.
Then average power, this is instantaneous power, average power over t second. That is P average is equal to E RMS, I RMS, cos phi, correct? That is equal to cos phi is 0, na? So only E
Yeah,
RMS
it
into I
will be
RMS.
1.
And that is, E RMS into I RMS is E RMS by R, na? So that can
Yeah.
be E RMS square by R.
Okay.
Understood? These are the formulas we are going to do in the numericals, right? Then let's once again so to see AC through inductor, right?
Hmm.
Let's see AC through inductor. Right, AC through an inductor. हमने प्योर इंडक्टर ले लिए, करेक्ट, उसको ईएमएफ दिए, इसका वैल्यू है L, इसका वैल्यू है E इज इक्वल टू E नॉट साइन ओमेगा टी, करेक्ट? यस सर, नो? एंड यू नो ईएमएफ अक्रॉस इंडक्टर, क्या पढ़े थे लास्ट? ईएमएफ अक्रॉस इंडक्टर क्या फॉर्मूला है?
E is equal to E naught sin omega t minus phi.
माइनस एल डी आई बाई डी टी, है ना?
Oh, that one, yeah.
Which opposes the growth of current. Inductor always opposes the sudden rise in current or growth of current, right? Inductor
Yes.
की प्रॉपर्टी ऐसा है कि always opposes the growth or sudden rise in current. The growth or sudden rise in current. Correct?
Yes.
देखो, ग्रोथ डिक्रीज अपोज करता है मतलब नेगेटिव है ना? तो हम ये
हाँ.
लिख सकते हैं कि यहाँ पर अगर हम वोल्टेज इक्वेशन डालेंगे, राइट, ई जो हमने दिए, उसने जो ईएमएफ इंड्यूस किया डी आई बाई डी टी, करेक्ट, इज इक्वल टू हाउ मच? जीरो. तो दैट मीन्स हमने जो वोल्टेज दिया दैट इज इक्वल टू एल डी आई बाई डी टी, करेक्ट? यस सर, नो?
Okay.
सो वी कैन राइट डी आई बाई डी टी इज इक्वल टू ई. ई क्या है? ई नॉट साइन ओमेगा टी, है ना?
हाँ.
बाई एल. अंडरस्टूड?
Understood.
अगर मुझे करंट निकालना है तो मैं क्या करूंगा? ऐसे लिखूंगा डी आई इज इक्वल टू ई नॉट बाई एल साइन ओमेगा टी डी टी, राइट? और बोथ साइड को इंटीग्रेट कर देंगे आई निकालने के लिए, राइट? साइन
I
ओमेगा
is
टी का
equal
क्या है?
to
कॉस ओमेगा टी बाई ओमेगा माइनस, राइट? तो ऑन इंटीग्रेटिंग यू विल गेट आई इज इक्वल टू हाउ मच? माइनस
minus E
ई
naught
नॉट
by
बाई
omega.
ओमेगा एल इंटू कॉस ओमेगा टी, राइट?
Yes.
साइन 90 माइनस थीटा इज कॉस थीटा ना? एंड साइन मान के हमने लिखे साइन, ऐसे हमने लिखे, करेक्ट? हम ओरिजिनल के साथ कंपेयर करना चाहते हैं तो साइन ई नॉट बाई ओमेगा एल, दैट इज विथ
Sin pi by 2 minus
साइन 90 माइनस ओमेगा टी, करेक्ट?
omega t. Yes.
और जब जब नेगेटिव को अंदर ले लेंगे तो क्या हो जाएगा? साइन ओमेगा टी माइनस पाई बाई टू हो जाएगा, राइट? अंडरस्टूड
Okay.
और नॉट?
Fine. Yeah. Understood.
So that means we got I is equal to, ये जो I naught है, right? So finally we got I is equal to how much? I naught sin omega t minus pi by 2. मिल गया ना हमें ये?
हाँ.
The expression for current in case of inductor.
Yes.
And we have discussed always current lags, right? And
Yeah.
what will be peak current? I naught is equal to how much? This is the peak current. Yes or no? E naught by omega L, correct?
E naught by, yeah.
E naught by omega L. And that omega L is known as XL, that is inductive reactance, right?
Yes.
This XL, this inductive reactance, XL is inductive reactance. We'll come to that. XL is inductive reactance, right?
Yes.
और यहाँ पर what is the phase difference between voltage and current? Pi by 2.
Pi by 2.
So here phase difference between alternating voltage and current, right? Between voltage and current is pi by 2, correct? ठीक है?
हाँ.
That means current lags behind the voltage by a phase angle of pi by 2, right? current lags behind the EMF by a phase angle of pi by 2. Correct?
Fine. Yeah.
Yes or no?
Yes.
Then phasor diagram. करेक्ट. अगर फेजर डायग्राम ड्रॉ करेंगे, ठीक है, ये मान लो ईएमएफ का, राइट, जैसे हम लेते थे यहाँ पर आई और ई, and this is for omega t, right? And you know this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, right? So current lags means it will start later, correct?
Yeah, at pi by 2 it will start. Yes.
And little less magnitude, correct?
Yes.
Didn't see it. Understood? अगर हम इसको फेज डायग्राम में ड्रॉ करेंगे, ठीक है, if I'll draw in phase diagram, then this will be like this: VL, right? IL. If this is VL, this is going to be current, right? pi by 2 पीछे मतलब लैग करता है, राइट?
Okay.
इसीलिए ऊपर में है VL और ये नीचे में है IL, राइट? Understood? Understood or not?
Yes, sir.
Okay. Next, let's know a little bit things about inductive reactance, right? Know about inductive reactance. Inductive reactance means the opposition offered by inductor to the flow of AC, right?
Okay.
Inductive reactance का मतलब क्या है? The opposition offered by an inductor.
Okay.
The opposition offered by an inductor to the flow of AC
Yes.
is called inductive reactance. It's called inductive reactance, correct? है ना?
Okay, yes.
That means it is analogous to like resistance in AC, right?
Yes.
तो अगर XL is equal to हमने क्या बताया था 2 pi FL,
Yeah.
तो अगर DC का फ्रीक्वेंसी क्या है? DC fixed value, frequency is 0. DC is constant, no frequency.
No.
Yes or no?
No.
So if I'll put F is equal to 0, then XL will be how much? 0.
0.
So XL 0 मतलब ये मतलब उसके थ्रू कोई भी रुकावट नहीं आएगा, इंडक्टर डीसी को नहीं रुकेगा, अपने अंदर जाने देगा, राइट?
Yes. So.
बट रोकेगा किसको? जिसका फ्रीक्वेंसी है एसी का. तो वी कैन राइट अ सेंटेंस हियर, इट अलाउज डीसी, but offers infinite impedance to the flow of AC, right?
Yes.
But offer finite efforts मतलब कुछ वैल्यू ऑफर करता है, but offers finite impedance to the flow of AC.
Okay.
Correct?
Okay.
And its value depends on L and F. XL depends किसके ऊपर? Depends on inductance value and frequency also, right?
Yes.
Right?
Okay.
ये मतलब inductor doesn't cause the current to lag behind, but it also limits the magnitude of current, right? Because you know I naught is equal to how much? E naught by omega L, na? Right? And that omega L is equal to what? E naught by I naught. That is XL, right?
Yeah.
from the division of maximum voltage to maximum current, you can also know what is the value of XL, right?
Okay.
And you know XL is equal to what we told? Omega L, right? That is 2 pi FL. Omega is equal to 2 pi FL. That means XL depends on frequency. Yes
Okay.
sir. अगर कहीं पे हम ग्राफ लेंगे, यहाँ पर हमने फ्रीक्वेंसी लिए और यहाँ पर हमने एक्सएल लिए, राइट? दिस इज वाई, दिस इज एक्स, है ना? तो इसका जो स्लोप देगा, क्या देगा मुझे? एक्सएल बाय एफ। यस सर, नो? अगर मैं इस
हाँ.
ग्राफ का स्लोप निकालूं, तो स्लोप मीन्स tan थीटा, राइट? tan थीटा मीन्स एक्सएल बाय एफ, and xl is equal to how much? 2 pi fl, na? 2 pi fl by f, how much? 2 pi l or not?
It is.
Understood?
Yeah.
अगर हम एक्सएल और एल का स्लोप निकालेंगे, क्वेश्चन में ध्यान से देखना, कभी कभी एक्सएल और यहाँ पर हमने ले लिए एल, राइट? Getting?
Fine.
So this is xl, this is theta, and here slope is going to be how much? No, sir, xl by l. xl is equal to 2 pi fl by l. L cancel, so that is 2 pi f. Okay?
Okay. Yeah.
And for high frequencies, फ्रीक्वेंसी लेट इन्फिनिटी बहुत ज्यादा हो गया, तो एक्सएल क्या हो जाएगा? इन्फिनिटी, राइट?
हाँ.
कोई कहीं पे अगर फॉर एसी हाई फ्रीक्वेंसीज एक्सएल इज इक्वल टू व्हाट? इन्फिनिटी, राइट?
Yes.
एंड डीसी कैन फ्लो इजीली,
Because XL will be 0, right?
no frequency, nothing, right? And you know
Okay.
XL is equal to finally omega L, sorry, omega not subscript L, it's omega L, that is equal to E RMS by I RMS, correct?
Hmm.
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 अभी चलते हैं पावर सप्लाई।
Power supply.
यस, पावर
It's
PL,
XL.
यस यस यस, PL इज इक्वल टू IV। I मतलब I नॉट साइन ओमेगा टी माइनस पाई बाय 2 ना,
हाँ.
और V मतलब क्या है? V नॉट साइन ओमेगा टी, करेक्ट?
Yes.
साइन A माइनस B इंटू साइन B, राइट? करेक्ट? एंड साइन 90 माइनस थीटा इज कॉस थीटा ना, सो यू कैन
Yes.
राइट माइनस I नॉट V नॉट साइन ओमेगा टी माइनस पाई बाय 2 की जगह में कॉस ओमेगा टी लिख सकते हैं,
Cos pi. Yeah. Cos omega t.
इंटू साइन ओमेगा टी भी लिख सकते हैं। एक 2 मल्टीप्लाई करते हैं, एक 2 डिवाइड करते हैं, 2 साइन ए इंटू कॉस बी साइन 2 है ना,
हाँ. So it
तो
will be
राइट माइनस I नॉट V नॉट
1
बाय
by 2.
2 इंटू साइन 2 ओमेगा टी, राइट?
Yes.
करेक्ट और नॉट?
Correct, sir.
दिस इज द पावर इंडक्टर, राइट?
हाँ.
और एवरेज पावर ओवर ए कंप्लीट साइकिल, डेल्टा फाइव पी एवरेज अगर हम निकालना चाहते हैं, पी एवरेज इज इक्वल टू ई आर एम एस इंटू आई आर एम एस कॉस फाई, राइट? एंड कॉस फाई इज 90 डिग्री ना यहाँ पर,
हाँ.
बिकॉज फेस
It
डिफरेंस
will
इज
be
90,
0.
तो जीरो,
It will be 0.
राइट? दैट मीन्स हम जो निकाले थे आई नॉट वी नॉट माइनस बाय 2 इंटू साइन 2 ओमेगा 2 जो हमने निकाले थे, राइट? दैट इज गोइंग टू बी जीरो। दैट मीन्स अगर ये पूरा जीरो हो रहा है, मतलब साइन 2 ओमेगा टी विल बी ऑल्सो जीरो।
Hmm.
दैट मीन्स इससे भी साइन का ओवरऑल कंप्लीट साइकिल में साइन का वैल्यू क्या है? जीरो है ना? यस सर, नो?
Hmm.
सो यू कैन राइट द
हाँ.
एवरेज ऑफ साइन 2 ओमेगा टी over a complete cycle is zero. Over a complete cycle is zero, right? So एक finally एक sentence conclude कर सकते हैं इंडक्टर के ऊपर। Average power supplied to an inductor, right? Average power supplied to an inductor over one complete cycle is zero, right? for one complete cycle is 0. Understood?
Yes, sir.